Welcome back to BBC America, hunting with natural predators. Here we have the Manx cat stalking its prey, the natural lizard. Come back soon to see how it works out. Oh no, it's gaining chase. Well, anyways.
Oh, hi, fourth graders. You see Oliver, he's hunting lizards. He doesn't hurt them, he just really likes chasing them around. He's already caught one today. That's okay, it was returned to the wild unharmed. But welcome. All right, what we're doing today is actually lesson 13-2. Assistant, can you see this okay?
I'm sorry.
Is it too dark?
Perfect.
Okay, so 13-2 is taking yesterday's lesson and sort of building on it again, just the same concept. So it's multiplying a fraction by a whole number. So keep that in mind, a fraction by a whole number, and by using models. So we'll start right away. I want you to look at 3/8. We kind of used this model yesterday. So what is 3/8? How can we break that down? Another way of saying this, if I were to ask you, what is the unit fraction? Yep. So you're saying the unit fraction is 1/8, correct? How many of them are there? 3. Oops. Yes. I've left my wiper inside. So it is 3 times 1/8. That gets you 3/8. So again, remember that multiplication is a shortcut for addition. So we could have written it just like this. 3/8 also equals 1/8 plus 1/8 plus 1/8. That's another way. But instead, we have a shortcut of saying 3 times 1/8. Again, unit fraction of 8. Okay, so that's just a quick review. So today is actually taking a whole number and a fraction and kind of multiplying together. So we'll go back to the antage of apples and bags. Let's see if I can get better bags today. So you remember my bags of apples? Oh dear. Oh gosh. Some of them turn out better than others. Okay. So we have 3 bags. Let's say today that we put 2 apples in each bag. They look like cherries, but they really are apples. So what multiplication problem would you use here? That's right. 3 times 2. So that's what we're doing today. We're actually going to take a whole number and multiply it by whatever fraction we see in front of us. Okay? Oh, here comes Helper Kitty back. Boy, really use that wiping cloth. Ugh. Okay. So let's just start with our first example. Oh, Oliver. Okay. So if I were to show you, I'm going to read you a little blurb. Okay. How much tomato juice is needed for a group of 4 people if each person gets 1/3 of a cup of juice? So each person's going to get 1/3 of a cup of juice. How many people again? I heard 4. So that's this. 4 people are going to get 1/3 of a cup of a juice. You're probably already seeing something in your head. You see it? Yep. 4/3 is definitely more than a whole. So we have to write that as an improper fraction. So 4/3. What does that equal when we break it down a little bit? So 3 will go into 4 one time with 1 remaining, and our third is going to be our fraction. So really it means 1 1/3. So if we were to multiply this out, it's really, another way of saying this would be 4 times 1/3. So there's our quick multiplication problem. There's 1, 2, 3, 4 times 1/3. So that's how we can write it in a multiplication problem. Let's go a little bit harder. This one, same people. You're going to serve juice again to 4 people, but this time each person gets 2/3 a cup. So let's go 2/3 a cup per person. So I'm going to write it out the long way so you can see this addition problem. Okay. So what does this equal? Well, you could go 2 plus 2 plus 2 plus 2 over 3, or you could simplify it, right? You could go 4 times 2/3. Yes, so 4 people get 2/3 of a cup. There's our simplification. Now yesterday I showed you this really slick algebra way of showing it. So you're going to rewrite it. It's 4 times 2 over the top of 3. So do the math. 4 times 2, 8 over 3. Way improper fraction. So now let's take this improper fraction Gosh, I wish I really had my wiper. This is not good. So 8/3, now converting the 8/3 into how many cups? So you're gonna go, 8 goes into 3 how many times? Well, 3 times 3 is 9, that's too big. So 3 times 2 is 6. Then I count up 6, 7, 8, 2/3. So you're gonna have 2 2/3 cups of liquid that you're gonna feed everybody. So that's sort of using multiplication to help you solve that problem. In a model, let's go back to this original problem. Let's go to 4 times 2/3. Okay. What does this look like on a model? So the unit fraction, same thing, is a third. So I'm going to draw a long fraction bar, and I'm just going to start breaking it up. I don't know, hopefully it'll come out even. So each one of these, so I'm going to say this is 1/3 here. Here's another 1/3. Yep. So what we have right here is 2/3. So I know there's one person's juice. I'm gonna just do another one. Just keep it as even as I can. Okay. Here's the second one. So it's now 2 people's juice. Okay. Another 2 for my people that are thirsty. So this is another 2/3. Now we have 3 2/3. And it looks like I made my line too long. Okay. And we have our last person having juice at 2/3. So what do we have here? Let's count it up. How many thirds do we have? 1, 2, 3, 4, 5, 6, 7, 8. So does this equal 8/3? Yes, it does. Yes, it does. So again, using that model, you could break it down like this, or you could just use the algorithm. Pretty easy. Let's just go right into some examples. This board is going to need extra cleaning. Ooh. This is why I don't let you guys use your hands on your board. So let's use example number 1. So if we said Milo runs 2/3 of a mile each day, how many miles does he run in 1 week? So Milo runs 2/3 miles each day, and he runs every day for a week. So that means it's really 7. I'm just going to show you this is not standard protocol. When you write it like this, you should put the whole number first. It's just a funny math thing. Dawson, do you know why they expect this?
I didn't even know that.
It's just usually a look. Okay, so 7 times 2/3 miles. So we're trying to figure out what Milo is running. So you could do that same model where you go 2/3 and that's 1 day, another 2/3 and that's 1 day, another 2/3, and that's going to take a long time to show it model-wise. Algorithm, it works really well. So let's rewrite this as 7 times 2/3. Okay, what does that equal? Yep, 14/3. Very improper fraction. And if you wanted to transform it into a mixed number, you're going to say, how many times does 3 go into 14? You can just do this in your head. That's right, 4 times, that's 12. I count up 12, 13, 14. It's just a little trick you get used to. So that's 2, excuse me, 2/3. So 4 2/3 miles would be what Milo ran in 7 days. Okay, that's kind of the job today. Let's practice with our first GP. So number 1 on your GP, the GP says 8 times 1/2. Here's the directions. Multiply. Okay, standard algorithm, try it. So it means 8 of these 1/2 pieces. So you could just go 8/1 or 8 times 1 over 2. So that really means 8/2. This is a division problem. How beautiful is that? 2 goes into 8 how many times? That's right, 4. So your answer is 4. So if you multiply 8 times 1/2 equals 4. And you can actually get something out if you want and cut it up. So you can say, okay, I've got 8 hats of something. What does it look like? Okay. Gosh, that was a mistake. Let's go back to number 2, GP. GP on number 2 says 13 times 3/4. Okay. Now, instead of doing the model, which would take you forever to do 13 of these 3/4 sections, so you could go, there's 1/4, 1/4, 1/4. Okay, there's one group. And you could do another 3 onto it. Okay, there's another 1/4, another 1/4, another 1/4. Okay, I have to get 13 of these groups. So there's 1. there's 2. You can kind of see, too much time. So just do standard algorithm. 13 times 3 over 4. Okay. Assistant, can you multiply 13 times 3 for me very quickly?
39.
Oh, thank you very much. 39 over 4 is what this equals. So you have to convert it into a mixed number. How many times does 4 go into 39? 9. 9 times 4 is 36. Count up. 36, 37, 38, 39. 3/4. So 9 and 3/4. And if we were going back to that question again, what is 13 3/4 when multiplied together? Oh, it gives 9 and 3/4 total. 9 holes with 1 3/4 left over. Okay. So again, lesson today is easy. Just multiply. Number 3. Okay. 7 times 2/3. Okay. You know the drill. What do I do first? 7 times 2 over 3. 7 times 2?
14.
14 over 3. Keep that denominator the same. 3 divided by 14. You're going to have to translate this to a mixed number. So it's going to go in 4 times. That's 12. 12 times 3. 12, 13, 14 with 2 over 3. So it's 4. The actual answer for this answer is 4 and 2/3. So you can multiply this and you get that. All right. I want to take you to, this is a tricky one. Number 5 actually is an explaining one. It says, write a multiplication equation. It says, medicine taken in 10 days if the dose is 3/4 ounce per day. So you know that you write an equation means, 10 days of medicine and you're taking 3/4 of an ounce each day. That's your multiplication problem right there. Algorithm, go for it. 10 times 3 over 4. So it's 30 over 4. This needs to be translated to a mixed number. What times 4 is close to 30? 7. It's 28. Count up. 28, 29, 30. It's 2 over 4. Can't leave it like that. One more step. This is the simplification needed. Another name for 2/4 is 1/2. So 7 and 1/2. That's the answer to that question. So it's 7.5 ounces within 10 days. All right, you guys, you're doing great. Keep standard. Don't forget to simplify. That's something I made note of many weeks in a row. Hang in there. Bye, 4th graders.
The wild beast has gone inside to rest his weary paws. For now, all creatures such as chickens and lizards are safe. For now.